Welcome, everyone. Thanks for joining us for another Hub Insight session. As we know before, these are absolutely fascinating and useful opportunities to get to meet members of our community, find out what their backgrounds are, how they've come to be involved with the Digital Twin Hub, and more broadly, how they've come to be involved with digital twins. We've obviously met people from quite a multitude of backgrounds. We've got David McKee with us today. I'm sure he'll have a different background again, so hopefully you'll all find that really interesting. David's the CEO at Slingshot Simulations, so I'm sure we'll find a bit more about what that is and what work they do. And then we've got some interesting kind of digital twin examples to dig into with David. And as always, I'll be asking plenty of questions as we go through. So David, how about you just kind of introduce yourself and kind of, it'd be quite interesting to hear a bit about your general background, kind of what did you go back kind of to university times, what did you study there, and how have you ended up where you are today, really?
Absolutely. Thanks, Sam. Looking forward to the discussion. So if I go back, I trained as a software engineer, did an undergraduate master's software engineering, and then did my PhD in real-time computing. So all about safety critical systems, processing high volumes of data in the cloud in real time to generate insights safely, so that we hopefully live in a safer world. The key, and that actually led to the key motivation that then a few years later, I then went and formed Slingshot Simulations, which was an interesting challenge that I was faced during my first, I think, 3 months of my PhD studies, where most of my colleagues were spending anything between 9 and 15 months of their PhDs running models and simulations because of the quantity of data and the complexity of things they're modeling. And I'm sat there thinking, I'm about to embark on 3.5 years of a PhD. If I get a simulation wrong and I'm 15 months in, how many more chances have I got to get that right before my time is up on that PhD? The answer is not very much.
Yeah.
Particularly if you start it in your second or your third year of your PhD. So I then embarked on a journey where I then built some of the original core stack for Slingshot to actually enable us to do modeling and simulation at higher velocity, quickly and easily. And that resulted in the core platform that is now Slingshot to allow us to do that analysis initially for PhD studies. And then we started rolling that into other projects, working with the likes of JLR, Rolls-Royce, Alibaba, and others to enable them to do data science much, much faster. And then we formed Slingshot, officially formed in 2019. We're coming up to 2 years old as a company now in a couple of weeks' time, which has been a fun journey.
Yeah, actually hard, I should imagine, as well.
Well, it needs to be hard, otherwise you don't have the enjoyment of the success.
Yeah. No, absolutely. So, jumping back a bit, what sort of kind of simulations and modeling was going on kind of at that point of time when you were going through your PhD, just out of interest?
So there was a mixture. So when you're doing real-time systems modeling, you're interested in 2 layers. So you're interested in the software architecture, so modeling that in terms of schedulers within the operating systems, what task, if you want to 1 billion people to watch the Chinese fireworks on Chinese New Year, well, there's a workload there that needs to be modeled and simulated, but then there's the underlying hardware that also needs to be modeled and simulated. And that then correlates to the fluid dynamics in terms of heat and airflows in a data center. So it's a really interesting mixed bag there of fluid dynamics, finite element analysis with process-based and event-based simulation, all coming in and fighting with each other to make that all work. So it really was quite a mixture. And then between 2013 and 2018, we actually translated that work and did a whole lot of work for 5 years with Jaguar Land Rover, looking at powertrain simulations, which actually some of the same things, because then it's about driver events in that agent-based world, and then the fluid dynamics and FEA type work they'd expect in traditional mechanical engineering. So quite a mixed bag there, and that's actually really interesting. And that's where, for me, digital twins become really insightful, because it's about these data models and simulations coming from these disparate worlds come together to bring you insights from those heterogeneous forms.
Thank you. Yeah, that is absolutely fascinating. So, looking at Slingshot, what is it in your mind? Is it a kind of tech? Is it a software platform? Is it consultancy? Is it a mixture? Where do you kind of see yourselves as a company?
So there's a bit of a journey there, and it's the journey that probably every company that has ever formed has been on and is going on, which is where as a startup you start as a consultancy. Because you have to find some revenue, you have to get people to try out your tech, and you go from there. And over the last year, we've been transitioning, interestingly during a COVID pandemic as well, to a SaaS platform, so a cloud platform, where anybody can just log on. Currently, we have a waiting list where we're slowly letting people in over the next few months to log onto the platform, build their own digital twins in seconds. So going from literally nothing to you being able to take your data sets, your IoT sensors, all of that, generate a model in 3D, 2D, whatever you want, run simulations and generate insights in the time you make a coffee. And that's where there's no consultant in the loop now. We're still there. We still do some consulting, of course, but we're very much a software as a service platform provider, enabling people to do things faster and cheaper.
Cool. So, I mean, I guess the million dollar question a lot of people are getting asked at the moment is, what actually is a digital twin when you're talking about it from your own or from Slingshot's kind of perspective?
It's simply a tool to make better decisions. And that's what it has to be. And it also should be a tool to make those decisions faster, and should be enabling you to do that easier. So, we talk about delivering capabilities in terms of delivering them in real time, delivering them in the time that you need to make the decision to respond to the event that is happening. Real time doesn't necessarily mean happening in milliseconds, but actually, if you need to respond to an emergency, well, you need to get the fire crews or the police there. It needs to be accessible. So actually, and accessibility is really interesting. It's one that's not talked about very much, because when we think about realizing the value of a digital twin, it's about reaching and engaging all the stakeholders across the value chain. So if we think, we do a lot of work in cities. So you have your AEC firms looking at it from a construction engineering perspective, data scientists, experts in their own right. You then have your policymakers who are experts in their own right and understand the other poles and the other strings that are needed in order to get things across the line. And then you have asset owners who have other strings pulling them as well. And actually, they've all got different backgrounds, but they all need to be engaged with the same digital twin, but probably a different view on that digital twin. And that's really important. So you have to make it accessible for the different stakeholders. So we focus a huge amount of our effort on that, in terms of engaging those people and making sure that it is accessible to each of those stakeholders at the cost that they can afford it at. So if you're a local authority, well, actually, you're not going to be interested in something that costs you hundreds of thousands of dollars because you just do not have the budget, particularly after a year of a pandemic. Whereas actually, maybe that level of cost is more acceptable to an engineering firm because you're used to that in terms of the engineering tools, and you're actually getting the value out of it because you're doing advanced analytics. Whereas in reality, your local authority, they want to see the reporting, they'll do some basic analytics, but they're not going to be looking at the camera on the road.
No. I mean, I've often kind of talked about how, kind of, as you said, when we talk about digital twins, not everyone necessarily needs to see the digital twin in the same manner. And I quite often talk about it in terms of different lenses to look at the same picture in many respects. And I know one of the areas of, I guess, kind of contention we often hit upon is, what's the difference between digital twins and modeling? Or is modeling and simulation just digital twins with a fancy name? Kind of, where do you sit in that kind of debate?
So I have quite a clear picture on this, and this also aligns with the other hat where I do quite a lot of work at the OMG around digital twins as well. And for us, it's all about the word synchronization. Because you can have the best model and the best simulation in the world, but if it's not based on real world data, that's the synchronizing from the real world into that model. Well, it's just a model. Could be the best one in the world, but it's not based off of the real world. And actually, if it doesn't feed back into the real world somehow, that could be via an actuator, so a motorized machine or something like that, or via a decision maker, it could be a policy maker, but there's some feedback loop. If it doesn't have that, you're not realizing the value of it.
Yeah.
So for me, I think about it personally in terms of TRL levels. So very kind of thinking about 9 levels instead of technology readiness. And actually we think about modeling and simulation sits at the bottom 3. It's like we're building up an idea, we've got a hypothesis of how this will work. We then talk about a digital twin, maybe of one component they've integrated with a sensor. We're proving this hypothesis out, and that TRL levels 4 to 6. And then we get into the systems integration, that holy grail of TRL that we sometimes wonder if we ever reach 9 in the real world. But that's where I start to talk about digital twin systems.
Okay.
Because there we're talking systems of systems thinking, integrating with IT, OT systems, all of that coming together. And that's where you start realizing the value. But it comes to that one word, is synchronization, which modeling simulation is part of, but it has to be tied together.
And in terms of into that picture, where does Slingshot kind of sit in that, in your mind?
So we very much sit on the space where we aggregate vast volumes of data from sources. So we expect there to be some mechanism for collecting that, and we will support a wide range of collectors. So these could be OPC UA systems, could be some RESTful interfaces, you name it, could be spreadsheets. So we support that. We then do modeling and simulation visualization. So that's sort of that kind of coming back to enable then a stakeholder to make that decision. So our system, although we talk a lot about digital twins, we will very willingly say, actually, until someone does something with it, it hasn't quite closed the loop. We're a tech provider, but we need you to actually make it a digital twin, which maybe is a slightly controversial thing to say. But I
think it's quite an important thing to say, though, because I think there is obviously a school of thought, and some people, in my mind, who misinterpret digital twins and kind of see them as this panacea where you've got a digital twin, your efficiency just improves tenfold as a result, which would be amazing. But machines can't always necessarily say what to do with the information. You've got to explain to it how you want it to interact with your system to some extent. And there's people that obviously can help you with that journey. But unless you get that piece right, you're going to spend millions of pounds on a digital twin that does nothing in its own right. And I think, yeah, as you say, it's a very important piece to get right. Okay, no, that's really good. I mean, I guess one of the things that'd be really interesting to hear about is, yeah, as you know, digital twins are often talked about in quite hypothetical terms. And I know we were chatting briefly before this call that you've done some kind of interesting practical applications. I think you were talking about one you were doing with satellite data. Did you want to kind of pick on one that's, I guess, of particular interest to you and kind of take us through it?
Yeah, I mean, I'll probably pick on a couple because I think it's always quite important to realize that the breadth as well that they can apply and where they start to interplay. So there's a piece of work that came to the public domain 10 days ago, which was presented at the NASA SMC-IT conference, which is the Space Mission Capability Conference, where we were looking at the correlation. So this is data coming from some of the NASA satellite missions, looking at the impacts and the predictions of lightning strikes with severe weather phenomena. So actually, there's a lot of data out there. And we're pulling that data in from streams, not quite real time because there's always a processing time from a satellite. Taking that, processing that, doing the analysis. The analysis was done in about 2 or 3 minutes. The upload of the data took a heck of a lot longer due to internet connections. Process that data and then show that to say, actually, you could start forecasting and predicting events of when is there likely to be, due to a solar storm, is there likely to be a severe lightning strike storm, such as the ones we saw in California last year, where I think there's something like between 14 and 16,000 lightning strikes in a 4-hour period, which is insane. That is a lot of lightning.
Yeah.
I mean, I'm not a photographer, but I can imagine that would be a photographer's dream.
Photographers and storm chasers.
It really would have been. But looking at that, that's a really interesting example at quite an extreme scale, where that could have huge implications on saving lives. If that then is realized to say, actually, do we need emergency response people available on call because we could have fires? We're seeing obviously the catastrophic effects of fires over the last few months and some of the ongoing effects at the moment in Europe. But let's take maybe the satellite data and bring it slightly closer to home as well. Another example that we did in the first quarter of this year, and working with Leeds City Council and another small company called SatSense, was taking the European Space Agency Sentinel-1 data over a 5-year period and looking at subsidence. So looking at ground movement. So this was being processed on a weekly basis, every 6 to 8 days, being refreshed. So we know we have that synchronization where this is periodically being refreshed into the system to actually update a model and say, actually ground in this area on a 3x3 grid, 3 meter by 3 meter grid, saying actually this ground has moved up or down. And based on that and correlating that with other data, such as where we know about buildings, what we know about other infrastructure and utilities and so forth, we can then inform asset owners and say, there's a problem here. This building has moved. I think there was one building in the center of Leeds that had moved just over 10 millimeters per year on average over the last 5 years. Now, I'm not a civil engineer, but I'm pretty sure that is not normal for a building.
Probably right.
So, actually detecting that, being able to realize that and say, actually, we need to do something. And in that particular case, the response would be, and that loop back in is that we need to send a surveyor to go and figure out what's going on so that can propagate that business value back in. So that's an example where it ties that loop. But you can apply that to everything, to transport planning. What about a bridge failing? Can you predict that there's some movement and that's going to cause it? Apply it to flooding. And so we did an example last week around looking at flooding prediction and the trends, particularly in Yorkshire where we are. There's a lot of flooding. There's a lot of flooding every year. And to a certain extent, you just get used to it. But actually, as you get used to it, you become passive. And actually, you need to see, actually, there is something going on here and there's correlations that need to be analysed.
I think jumping back to the subsidence issue, I think that's a really interesting example, because I guess if they'd produced the digital twin of the building, the likelihood is that they were probably going to be looking at kind of the internal structure of the building, the electricity flows, all of those sorts of things, which is a normal bound to a system. And you kind of get into that position where, okay, maybe you should look at subsidence, maybe you should look at weather, and you kind of got an infinite number of things you could measure if you wanted to. But I think this is where it's an important part that a single digital twin doesn't need to be all encompassing. But having a digital twin of ground subsidence means not every digital twin in that space has to model its own ground subsidence, which is a much more useful way, in my mind, of reflecting it.
Yeah, I think you've touched on something there, which is the collaboration between the various vendors as well, and the role there that you have of standards. And these might be formal IEEE, ISO standards, but also might be de facto standards. That are just adopted best practice. And actually being able to say, okay, you've got, a Revit model, for example, of your building. It's been used by the architect. Well, okay, that's great. But then you've got maybe a standard model that's come from the sensors in terms of people movement. Someone else has done the utilities, because we all know there's been about a dozen different vendors involved at different stages of that life cycle. And we at Slingshot have really come into this and said, actually, we're not there to compete with that at all. We've got our own specialisms in massive scale data science, but we will say, actually, we're going to work with the best players in each of these, because actually each of them has something of value that they can bring. And it's really, really important that it's not just about us, it's about an ecosystem that needs to collaborate to bring better value. And we need to work together to find out how to do that. And there's a lot of learning still to do as we go down that journey, as you guys well know.
I think you're completely right. Well, so I know we've got about 10 minutes left. There's something I guess we haven't really been able to cover on any of the Hub Insights calls so far. So I'm a software engineer by background as well. And it'll be quite interesting to hear, because I guess you're pretty well placed on from a kind of computational or software side of things. Where do you see kind of the challenges in the digital twin space? What do you think may be holding people back? Or is it all kind of cultural and kind of information management challenges that have got to be dealt with?
It's a good question. Very good question. My instinct, and this is probably kind of from where I'm wrestling with it within the within OMG and the Digital Consortium, because I chair the working group on software open source stacks. And what's quite interesting, the area that has the least traction and least discussion is really around modeling and simulation, looking at it from an interoperability standpoint within those. How do you get different vendor tools to talk to each other? As a community, as a software community, regardless of domain, we're not very good at doing that.
Yeah.
We just had 25 years of failing at it, at least. We're very good at failing. But actually so that's one area, that's one really important area, making these tools talk to each other in a seamless way and without losing too much data when you move between them. So that's one real area. The other one, which is kind of tangential to that, is actually getting data into these platforms. So we're seeing an awful lot of work coming out of the Industry 4.0 program, out of Germany and so forth, around the asset admin shell and OpenSea UA. There's some interesting work coming out of some of IBM's colleagues, which they've open sourced a framework that is colloquially known as the Frankenstein framework, that basically seems to integrate virtually every ecosystem under the sun. But there's integration of these different pieces is still really hard. And it's because nobody is fully standards compliant. And that was one of the other big reasons at Slingshot, we probably spend 40 to 50% of our time automating integrations. So when I go and approach a customer, integration should be my problem. It should not be my customers unless they're software engineers. So we work very closely with the standards bodies, with the various industry bodies to say, okay, Autodesk, Bentley, Esri, whoever you are, we're going to make sure we support your format so that our customers do not need to worry about this whatsoever. So because data integration is probably one of the biggest pain points. And that is one of our biggest pillars that we focus on automating. The third and final one is actually the user experience. And actually user experience has historically not been great. And actually guiding users through a mechanism that means they make good design decisions. Maybe if it's just structuring a Revit file correctly, so you have the right hierarchy of assets. Little things like that actually can make a huge difference when you get 3 years later and you think, what on earth was that? Yeah. So structuring your information. So those are the key things. And I mean, the latter two is where we really focus as a company. And the first one, to focus on kind of our work with the standards bodies.
I mean, I think it's quite an interesting one, because I think if you take the built environment as an example, I guess modeling and simulation type stuff has been dominated by a few quite big companies. And I think with digital twins, I'm sure there will be some bigger players, but I think there is going to be a lot more people and organizations involved in that. And I think that obviously is going to make that integration and interoperability piece massively important. And we're seeing the likes of Microsoft, Amazon, they're starting to look at digital twins as, oh, this is a big thing. We should be getting involved in that space as well. And I think it'll be interesting to see how it kind of unravels, because you take cloud as an example. It's really not a particularly regulated place with standards, but the solutions they've all developed are quite similar. And from a customer point of view, I'm sure there's interesting proprietary stuff going on behind the scenes, but they've kind of naturally converged on a sort of standard. Whereas I think because of the multitude of applications of digital twins, we can't go fully kind of, right, let's just see where natural evolution takes us and survival of the fittest. So I know within the program, we're thinking about where and when can we start to bring standards in so that we can start to provide some framing to this. And where is, I guess, within the groups you're involved with, where is standards kind of sitting in that conversation at the moment?
I mean, I would say standards sit in almost every bit of it. So, and in a couple of different ways, because one, it's standard data formats. Okay, is there also standard good practice, maybe from a security standpoint? So that at every stage of that, you have to consider, well, what are the standards or best practice for the given domain we're currently working in? And that's the key. My customers should not be concerned about standards within big data processing, cloud computing, AI, machine learning. They should not have to care about any of that. That's my problem. And in reality, they shouldn't really have to care about IoT standards either. I have to sort that out with the vendors. What they should care about is what is best practice in terms of managing their information and their data. Because if they can do that, they can reduce their costs big time. And we do work a lot with a lot of the players in the ecosystem to say, actually, how can we help you? Even if they're not a client, how can we help you get across some of these hurdles? Because, it's just going to make life for everyone easier further down the road. And that's the key thing.
I think it's been quite nice actually with digital twins. We've seen quite a community spirit, because I think everyone knows it's hard. I mean, if it was easy, we'd be 5 years further along the road than we are. And it doesn't mean it's not possible. It just means it is a hard process to go through, but one that the only way we can do it is by working together as a community, supporting each other, and kind of, when the opportunities come to make strides, we make strides in those places. But I guess what would be an interesting thing to hear from you is, what are your kind of hopes and aspirations? Where would you like to see it in 5 years' time? What does kind of things going in the right direction look like to you?
So, I mean, I think ideally, I correlate this back to the world of cloud computing. So 5 years ago, 10 years ago, most people didn't know what it was. 5 years ago, a lot of industry still didn't trust it.
Yeah.
And now the majority are either on it or moving towards cloud computing. And there's a journey there that people need to go into. And I would hope that the same thing happens with digital twins, which may mean we stop talking about digital twins because it's just there. And we start talking about the benefits of, actually, we're able to use this and we're able to make these decisions. Look, we're able to save this many people's lives. That's much more interesting and much more important than the tool chain and the stack underneath. And for us, and the way we're currently positioning Slingshot at the moment, we're doing a piece of work this month on it, is we're deliberately saying, actually, at Slingshot, we want to make sure that every single person who's in a position to make decisions can access this type of technology. So whether you are someone who runs a fish and chip shop, or whether you are a multi-billion-dollar enterprise, you've got decisions you need to make. And therefore, we need to make these tools available to you at a price point you can afford. And it's a completely different ballgame at those different ends of the spectrum. So we're doing a huge amount of work to try and actually find the way to create those entry points. Because it's different people, but they've all got decisions to make, and it all cascades into actually making the economy stronger. And boy, we need that at the moment. This is absolutely fascinating. I could go on talking about this all day, really. One final, I guess, question, and kind of, I don't think it's a completely answered one, so I'd be kind of interested to get community thoughts around this afterwards. Obviously, please feel free to comment or join the discussion channels. But one of the bits I think is often dangerous when you start to bring large quantities of data from disparate sources together. You inevitably lose some fidelity or information about that data. And I think one of the important things is trust, or kind of error management in that data. How do you persist that and make sure that the person or the machine that's making that decision at the end of the day is doing it under the understanding that assumptions have been made, or we've had to kind of aggregate or disaggregate this data, and that means something when you do it. What's your kind of thinking, or what Slingshot's thinking around how you go about tracking that problem? One, it's a headache.
Yeah,
that's the primary response. It's a headache. I think there's a couple of things that come to mind, and one is audit.
Okay.
Is actually, to a certain extent, you need to recognize it's a problem, but also recognize that you can't fully solve it. You can throw the best machine learning at it, and actually all you're going to do is create another black box that might come up with the right answer, but the problem is you will never know if the next answer it comes up with won't be a wrong one.
Mm.
You just cannot know. And of course, a human, the same thing happens, but it's a black box. So, and obviously there's been a lot of talk around bias and explainable AI, understandable AI. All these things have been very much discussed at length over the last few years. But actually that audit, a level of transparency to say, this is where the data came from. And say, right, Sam, you uploaded this data set. You uploaded it at this time, and you said this information. Okay, well, unfortunately, we're just going to have to trust you.
Yeah.
You know, right, you're the original source of that data. What license did it have? Who did you get it from? Fine. If I then go and change that, we need that change log. We need that version history to say, I've now done this to this piece of information. I've performed this analysis, and I've generated a new data set. But that needs to be relatively transparent. And I might not want to necessarily show exactly what I've done from an IP perspective, because there's definitely some very clever people out there who rightly want to protect their IP around how they manipulate data. And that's one of the other challenging bits, is how you protect that IP whilst creating a level of trust. So that's probably the trickiest area that we're battling with. We've got some interesting ideas around that, but I won't share them yet.
No, thank you. I mean, as you say, it is really hard, and there probably isn't a perfect solution out there. But I'd be really interested, when people are watching this back, if they want to chuck their own thoughts in the discussions or in the comments, and see what ideas others have got about how we could approach this. Because balancing that transparency and protecting people's commercial interests, that's not an easy thing to do. And I guess accepting it from the outset that things will go wrong at points, and how do we handle it in those situations as well. But thanks ever so much, David, for talking to us today. It's been really, really interesting. I found it absolutely fascinating, and I'm sure we'll do this again in a couple of years, and we'll see where Slingshot's got to with some of these problems by then. But thanks everyone for joining. I hope everyone else has found it as useful as I have, and have a great day. Thanks very much. Thanks again, David.
Thank you.